Hello. This movie is to derive the equation for a circle. So we're going to look at equations for circles on the coordinate plane and write equations for them. So as we know from our past, here we have y equals 1/3 x minus 4. That's an example of a linear equation in slope-intercept form. Y equals x squared minus 2x plus 8 is an equation. It's a quadratic equation, and if I were to graph that, I would get a graph of a parabola. This is 2x minus 3y equals 6 is a linear equation, but it's in standard form. So we have lots of different equations that we've been dealing with. What I want you to notice is that for each of these equations, we have an x and a y. In fact, in our quadratic, we have an x squared and an x. But in each equation, we have an x and a y. So we are used to seeing x's and y's in the equations that we deal with. Now, note, each equation has an x and a y in the equation. That's because the x and y are going to represent many coordinates, x and y, that make up the graph. So we need those variables in the equation. For example, in our linear equations in slope-intercept form, I might say let x equal 3. And if x is 3, what's y? And you would plug that in to get what y is, plot that point. You could do that over and over again, and all of these points will form the line, giving you the linear equation. Just like the quadratic equation, you would do the same, and it would give you a parabola. So the same is true for our circles. Our equation for our circles on the coordinate plane will not be any different. They're going to have an x and a y in the equation. So I do want you to get used to that idea. Now let's see if we can derive the equation for a circle on the coordinate plane. We're going to call the center an h and a k, and yes, we always use h and k to represent centers of circles. We are also going to use a radius for r, and we're going to pick a random point on the circle xy. Now keep in mind our xy, our random xy's, are going to represent all the points on our circle. Just like the random xy represents all the points on a line for our linear equations. Now what we need to know is the distance formula, because we're going to use the distance. And the distance formula is big old square root of the change in the x's, x2 minus x1 squared, added to the change in the y's, y2 minus y1 squared. And we've seen in the past how this distance formula is also like the Pythagorean theorem. So we're going to see that to be true here as well. So what we're doing here is we're saying that the distance between these 2 points, which happens to be our radius, so I'm going to plug the radius in for d, is going to be the square root. I'm going to let this be my x2, y2, and my center is going to be my x1, y1. I'm going to plug this into the distance formula. So I'm going to get x minus h, because my x1 is h, quantity squared, added to y minus k, quantity squared. Now we're really close to the formula for, or the equation for a circle. See how I've got a square root? If I square both sides, then I get radius squared is equal to x minus h squared plus y minus k squared. And that is the equation for a circle. Let's highlight a few things. First of all, here's the x and the y we were talking about. Any equation is going to have that x and y. This r represents our radius. The h and the k is our center of the circle. Our center of the circle is found at the ordered pair HK. So those are actually going to be numbers. The R, the H, and the K will actually be numbers when we're dealing with a specific circle on a coordinate plane. Notice this is representing the general case because I actually don't have a coordinate plane. I have random variables representing these points. So that is the equation using our distance formula. One thing I also love is the Pythagorean theorem, and we know that these are cousins, so I'll go through this real quick. To get this horizontal distance here, it's the difference of our x's. because it's from this x to this x. So it's actually our x minus h. Those are our two x's. This distance here is between the two y values. So this is going to represent y2, which is y minus k, which is y1. So if I were looking at it as a Pythagorean theorem, I would get that r squared, the hypotenuse squared, is x minus h squared, that's one of the legs, plus y minus k squared, and that's the other leg. So you can also see that from the Pythagorean theorem, you get the exact same thing. This is what we call the equation for our circle on the coordinate plane. So, standard form for the equation of a circle with the center at hk. Now, these are just representing points. The center could be at 3, -7, or 8, -10. But that's what h and k are representing. And a radius of r is going to be x minus h quantity squared added to y minus k quantity squared equal to r squared. Keep in mind this x and the y are the only two variables you'll see when you're dealing with a specific circle. Now, some other ways to write this equation, you might see that the r squared is on the left side. So you certainly could see this. And that would be equivalent. I definitely would be not upset. That would still be standard form. So this one's okay. But another equivalent that you would want to simplify is if you had the radius is equal to the square root of. Now it's equivalent, but it's not simplified. Now I do want you to notice here, this is something that always happens. Because of the squareds here and the square root, they do not cancel out. And the reason that they do not cancel out is because of this addition. That addition messes it all up. You cannot cancel out the squareds with the square root because of the addition. So really, really, really important. Just real quick, I'm going to take you through a specific example here just so you can see the equation of a circle. So center, let's say, is at 2, -7. Radius is 4. Here's how you would write the equation for the circle with a center of 2, -7, radius of 4. You would do x, because x is in every equation, minus h. Now h is the x coordinate of our center, k is the y coordinate of the center, and this is our radius. So it's x minus 2 quantity squared added to y minus a -7. Now notice it's a minus -7. We'll have to simplify that. Is equal to the radius squared. The radius is 4. So to simplify this, we get x minus 2 squared added to y plus 7 squared. And 4 squared is 16. So this would be our standard form for the equation that has a center at 2, -7 and a radius of 4. All right, I'm going to walk you through this one, and then the next one I'm going to have you do as your formative example for this. Given the center and a radius, find the equation for the circle. Well, our center is located at, this is -3, 2. This point is at 1, 5. And the problem right now is I don't have my radius. So I'm going to use the distance formula or Pythagorean theorem to get my radius. I really need to find that radius length. So my radius, I know, is going to be, now you could use again distance formula or Pythagorean theorem. I'm going to use distance formula, which is the square root of my change in x's, which is my 1 minus -3. My change in y's, 5 minus 2. So my radius is 1 plus 3, 4. And this is 5 minus 2, which is 3. Square root of 16 plus 9. Square root of 25. My radius is 5. So now I know what my radius is and I know what my center is. Those are the two things that you need to know to write an equation. My radius and my center, this is my h, and this is my k. So now I'm going to write my equation for a circle, which is x minus, and I'm going to bring in that h right here, quantity squared, added to y minus, and I'm going to put in my k right here, equal to my radius squared. Oops, I forgot the squared. There we are. So that is my equation. I got to plug in the green things. I got to plug in the h, the k, and the r. So I'm going to get x minus negative 3 squared plus y minus 2 squared equal to my radius squared, which is 5 squared. And I'm going to simplify this. This becomes x plus 3 squared added to y minus 2 squared equals 5 times 5, 25. And that is my standard form for the equation of this circle. Find the equation of the circle, and that's how you do it. You got to get your radius, you got to have your center, and then you write your equation. I'm going to have you do this in the formative example. You could pause the movie, do this now, and then input your answer, but it'll be exactly this question. Thanks for watching the movie.